Hello everyone, I am Muskaan Rawat and I welcome you all to the 3-minute presentation of my project. In this video, I'll be talking about solid-state NMR spectroscopy of battery materials. First things first, let's get to know the basics. What is NMR or nuclear magnetic resonance? Consider these as two bar magnets, the fingers being the north pole and the bottom of the palm being the south pole. When magnet A is oriented in this way and magnet B in this way, what will happen is magnet B will orient itself in this way such that the opposite poles of both the magnets attract. What is happening is magnet A is providing an external magnetic field to magnet B which orients itself accordingly. Now this is exactly what happens in the NMR spectroscopy machine. The nuclei of the atoms and molecules behave as very tiny bar magnets which orient themselves in the direction of the external magnetic field provided by the magnets in the NMR spectroscopy machine. They either orient themselves in a parallel or an anti-parallel direction. The ones that orient themselves in the parallel direction form the lower energy state, while the ones in anti-parallel direction form the higher energy state, creating an energy gap between both the energy states. When a radio wave is emitted on these nuclei, a transition occurs from a lower energy state to the higher energy state. That is, the ones that are parallelly oriented orient themselves into an anti-parallel direction. When the frequency of the radio wave is such that the energy of the radio wave is equal to the energy gap of the energy states, the transition from lower energy state to higher energy state occurs. This phenomenon is called as the nuclear magnetic resonance. The solid-state NMR spectroscopy is a powerful tool used to analyze the structure, the dynamics, and the chemical properties of various compounds at atomic and molecular level. It can be explained through 5 key concepts, which are sample preparation, magic angle spinning or the MAS, the pulse sequences, chemical shift and spectral analysis, dipolar couplings, and spin dynamics. The task of my project is to perform solid-state NMR spectroscopy on Na3AsS4 and Na3SbS4, which are used as electrolytes in solid-state batteries. Solid-state battery materials are being widely explored and researched since they have better conductivity and longer lifespan than the conventional batteries. Both arsenic, As, and Sp antimony belong to the group 15 or the nitrogen family of the periodic table. Both the compounds lie in the superconductivity region and hence studying the structures and properties in detail would prove to be very beneficial. Both the compounds were synthesized through solid-state synthesis methods. Solid-state NMR spectroscopy was performed for 23 Na and 75 As nuclei for Na3AsS4 and 23 Na and 121 Sb nuclei for Na3SbS4. I am also working on the DFT calculations and simulating the NMR spectrum through various softwares like CASTEP and WSolids for these compounds. So this was all about my project. I hope this presentation intrigued you to dive deeper into the world of NMR. Thank you.